Hello. Uh, hey guys, let's continue with the paper 2. So, this is uh, actually, I don't know about the paper 1 or 2, but I was solving this paper, and I think we just stopped at question number 9. So, let's continue from the 10. So, I think 9 is finished, which is yes, it's option number D is the correct one. M omega naught upon capital M plus 6 times a small ms. So in this question we just applied the conservation of angular momentum, as you can see, and let's move on to 10. So again, solution. And in 10 number we have sigma. So yes, there is a disk of mass capital M, radius r, and has a mass per unit area is given as sigma kr square. K is constant and r is the distance from the center. And we have to find the amount of inertia about the center of mass and perpendicular to rest plane. So we can apply, I think we needed a diagram here, but I don't think we need a diagram. We can just continue without any diagram. So here's some suggestion by the copilot. Let's continue with the suggestion first. So yeah, as you can see, we know amount of inertia as rs square or dm. Dm, let's put that in bracket, and this will show. I think there is a command called d, and I'm gonna use this command. So let's because Copilot doesn't know about the d command, so it's just overriding. So let's run it first, and as you can see, I is equals to r square dm, or you can say mr square, but m is differential, so r square dm is the formula for the mode of inertia. So this is the disk, but we want like a ring. Firstly, we have to assume a ring as a differential element on the disk, and I think we needed a diagram here. I'm just explaining, and it's not very clear without diagram. So let's continue with the diagram. So begin center and begin text picture, yes, and now we are gonna draw some I don't think I need to. I think let's define coordinate first. So tz coordinate, and we can put dot. Yeah, it's right. So this is the coordinate O at the 0, 0, and let's make a circle. Tz circle. Actually, tz plot is a text based library. I am using that. So tz ring is another command, and let's run this first. Something is wrong here. Let's see the documentation of tz. So I think so just we have to search tz ring, and it will just take it, yes. So Yes, tz ring is a command basically, and it is the start command. Start means we have to fill something, and also just we put it the wrong coordinate, like again we have to use. So yeah, as you can see this is the ring, but we have to uh, make this ring thinner. So I'm gonna put 1.25. So yeah, as you can see this is much thinner, but you can decrease even further, and now we can make the circle of 2 unit. So as you can see this is the circle, but we assumed a thin ring of thickness d. Let's point out all these thing, digital line, and I wanna line, let's say uh, arrow, and from O to 1, so 1 comma 0, and we can use plus symbol here, and then we can put node. Node will be like r, smaller r, and node will be right. So yeah, as you can see I think midway below, so r will be in the middle. Yes, at r distance we have a thin ring which has the uh, actually we can use pattern lines. Yeah, pattern color, I don't remember exact command about the pattern. Let's see, let's see black, what happens, then we can improve upon that. Yes, it's filling black, but for right now just leave it that way. And one more thing I have to do is just have to put node as dr side by the ring. So I think a ring looking much thicker, so let's say 1.15, and we have to put tz node at 1 comma 0, and this will be like d of r. Yes, d of r, and this will be right side. So as you can see this has the thickness of dr. Now it's easy to explain everything. So we are gonna find we are gonna find uh, the moment of inertia of this ring. For that just we applied r square dm. So r square dm, dm is the differential mass of this ring. So sigma is the mass density and dA is the differential area. And now we can just proceed accordingly. Kr square is the mass density and dA will be 2 pi r into dr. Then accordingly we just followed, and we got the answer. But one more thing you have to find out, that how we get 2 pi k r 6 by 6 into 2 mr square is not very clear. So we are gonna solve something else as well. So uh, I think we have to solve this. Let put it in, put it into like sideways or column wise. I don't know where to put it. Obviously I don't know what to do here. Oh, without let's firstly I can, let's use column, begin multi-col, multi call, and this will be 2, and end multi call, and we have to wrap this thing into multi call. And now we can basically solve that part as the right column. So begin align, and we are gonna solve mass, right? So M should be like this, sigma dA, yes. This will be the right, and sigma 2 pi r dr, yes, sigma as a function of r we can put in much better form. So sigma as a function of r, and now we can put sigma as a k r square. So yes, let's run it first, see what happens, and then we can change accordingly. So there's an error and we don't know what error is about multi-call. So they I don't remember exactly, but I think I'm very certain about this, because there is a package which needs to be used. No, sorry. I think this is multi-calls, not key multi-call. So this is multi-calls, and now we can check this out. Oh yes, as you can see, this is multi-call, and we ran it and we are successfully. So I think just we have to make a sort MOI of it is. This will provide proper space. Why this happening, man? Space. I should have used mini page. Mini page is much better than multi-call, but I thought multi-page is suitable here. I don't know what to do. Let's continue with this, then we can see. And then int from 0 to capital R. Then again I can say int from 0 to capital R, and now we can point out r square by 4, yes. Then no, m is equals to I think 2 pi k we have to replace. So just we have to use 2 pi k is equals to 4m upon rp power 4, yes, that's right. So we have this value 2 pi k, and now we can put that into anything. Where is the problem in multi-calls? I don't know what to do here. So basically I think can I do this in the same alignment, or let's do it first, maybe that will solve what our problem. Let's run it first. Oh yes, that's this only one concurrent view. Okay, let's continue. So yeah, it solved the problem, I think. Just now, as you can see, value of 2 pi k is 4m upon r p power 4, and just we can put it here, and it will provide the answer for my difference here, which is 2m upon 3r square. So yeah, question number 10 is completed. Now we can move on to 11. 11 is pretty simple, I think. It's just a cross product, but let's see what we can do here. Again, we have the mass of 2 kg, because every unit is in SI unit, so we have the mass 2 kg and time 2 second, but we have the position vector as something. So firstly, we have to find the velocity vector, because to find out the angular momentum we need velocity, position, and m. We can apply the equation for the angular momentum, which is r cross p. So let's calculate firstly inter text velocity, or we can solve directly. I don't know what is angular momentum. If I can solve, no, from every method you have to find the velocity. Just let's see, velocity r cross p is right, and r times m cross v is right. Yes. Wow, I didn't think of that. Go for it, just helping. Yes, as you can see, apply the equation of angular momentum r plus p, and now replace p with mb, and then we can use dr upon dt. So let's continue with that, what it suggests. So let's run it first. Maybe it's that. So it is going to do I cap, no, it's messing thing up. So let's continue with what is does better times m. Then we have to differentiate, which is, oh yes, it's right. Wow, from where it got this intelligence? I think it's much intelligent than I thought initially. So yeah, 2 I cap minus 60 j cap, and now we can put this. 2 I cap, no, it's just messed up. I want to put r as the vector, which is 2t I cap on 2t hat I cap minus 3 we should keep the m outside. So m, and then left, and then we should left, and then we can put here right part. Let's run it first, then see what happens. Yes, as you can see, it's perfectly right, and now we can apply the cross product. Let's see what it got. So no, it does nothing, just a crap. So let's multiply manually. So I cap cross I cap will be 0, so here it's minus 12 t square, and I cross j will be k, so it's k cap. And let's put j cross I will be minus k minus minus plus, that means 6 t square, 6 t square, then hat k cap. Yes, it's right. Now we can put, I think, wow, it got some intelligence. Now we can put the time. Wow, it's marvelous. Yeah, so angular momentum is minus 48 k cap is the right answer. So Copilot is helping pretty much all the time. Now let's move on to problem number 12. And let's begin the LM environment. And here we have a hollow cylinder which will act like a ring. So a hollow cylinder attached with a string and a mass. We can just apply torque equation and then apply the condition for the raw length, because string is not slipping on the cylinder. So A is equals to R alpha linear acceleration, or you can say tangential acceleration is equals to radius times alpha. I don't know, should I draw a diagram or not, but I think without diagram it will work. Why it's suggesting like that? Should I conserve the energy? No, I think energy consumption will not solve the problem. Yes, that will help, but I think that will be much longer because it's asking for the acceleration. So just we have to apply torque is equals to I alpha. That's it. Actually, we have to draw some diagram that will clear the idea. So let's begin with center and takes picture. क्या हो रहा है मुझे यार? So we're gonna just copy this part. Oh, one more thing I have to do. Excuse me, guys. I need some break. My throat is like on fire. Okay, I'm back. So firstly, we are gonna separate this pulley and block and draw the ABD, right? For that we have to just remove this picture which is the top part and cycle. I think this also can removed and line which is anchored or I think let's run it first. Let's see what happens. So nothing. We have to. Oh, I think we made an environment where blank line is not allowed. So yeah, we have this pulley. Now, we can separate this block. We can shift to where maybe 2, 3, 3 units. Oof, pain. Let's put stealth or arrow something and call it tension, which is below, and from block we can again draw a line which is let's name it first. Let's call it block. So yes. Oh, I think I have to stop. Let's continue for 4. Block dot north, and then from there we can move to unit, and then we can put tension as if this side with the arrow. And one more thing I have to do is block. Oh man. Let's continue for 5 more seconds. Blockers. I continue, I remember. And in the down part it's mg, which is the force. For few seconds I won't be speaking, just coding and writing equation. Okay, I think that will be much better, because whenever I speak I get that cause. For 2 units, 2 units is I think much larger. I think 1.5 will be fine. So yeah, this is how we can do thing. And one more thing, I can copy from here. No, it's way up. Let's draw an arc here so that it will represent kind of alpha thing. So let's t-shade arc which is as center, and 180 360. No, I think we should start from 180 to 0. Then radius should be 1.25, and we can write alpha towards right, and this should point as arrow. That will be much better. So yes, as you can see, ABD is fine. Now we can move on to the equation. So Grab to stop. Oh man. uh, Torque is not zero. Why components is like that? uh, Sorry guys, I have to stop